For this video, I'm going to be using mapping notation to show all of my work. And in terms of the transformations, you can look at the previous video for those. So for this mapping notation, we have xy is going to become x plus 5 and negative 2y. For our base graph points, we're going to have negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Okay. So we're going to add 5 to all of the x coordinates, and that will take care of our translation 5 units to the right over here. So that x minus 5, that's how we get this plus 5 units to the right. Okay, and then this negative 2 in front, that's our a value. So that causes our graph to be vertically stretched by a factor of 2, as well as reflected on the x-axis. So we multiply all of our y coordinates by negative 2. Negative 8, negative 2, 0, negative 2, negative 8. Okay. Please make sure that you always label your axes, your scale. Okay. 3, negative 8. Oops, we have 4, negative 2. 5, 0. And then we have the mirrored points, like so. And then we can just draw our curve through those points. And that's our first graph. Okay, let's move on to the next example. So for this, because you have here, you have an a value, you have a b value. Once you factor out the 2, you'll have this d value of 3, and then you have this c value. Okay, you can keep this function the way it is and write down the transformations as xy is going to become half x plus 3 and then half y plus 1. So this is the a value, 1 over 2. This is the b value, but it's reciprocal, so 1 over b. This is the d value, translating 3 units to the right. Okay. And then this is the c value of translating 1 unit up. But if we were to use this transformation as written, it would be hard to have a very accurate graph because we would horizontally compress by half and also vertically compress by half. So instead of doing this, I'm actually going to delete what I have here. Okay. We are instead going to use equivalent transformations. Okay. So what I will do is I will rewrite this function as y equals half 2 x minus 3 squared plus 1. So far I've common factored out the 2 from inside the brackets. And then what I'm going to do next is this 2 squared here I'm going to bring out that 2 squared so that I end up with half times 2 squared times x minus 3 squared plus 1. So what that will do is this will give me 4 over 2, which is 2. So all of a sudden, instead of having both a vertical and a horizontal compression by a factor of half, I only have to worry about a vertical stretch by a factor of 2. Okay. So based on this now, let me state my transformed mapping notation formula. So this is going to be x, y becomes x plus 3, 2y plus 1. So 1 over bx plus d, ay plus c. So that's the a value there. This is the c value here, and this is the d value translating 3 units to the right. So again, once I have this, then it's a lot easier to determine my transformed function points. I'm negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. So I'm going to end up with adding 3 to all of my x coordinates. And then for all of my y coordinates, I'm going to multiply by 2 and add 1. So 9, 3, 1, 3, 9. And now I can plot these points down. Again, please make sure that you always provide some numbers on your axes for your scale. Okay, I can't fit 1, 9 on this particular grid, so that's fine. I'm going to leave it off. But I can put down the point 2, 3. I can put down the point 3, 1. And then I can also put down the point 4, 3. Okay, and that's enough for me to draw my parabola here. Like so. Okay, so let's keep going with this last example on this page. We have our root function. So now for this root function, we're going to factor out the half. So any coefficient of x, we always want to factor that out. When we do 2 divided by half, same thing as 2 times 2. So we're going to have x plus 4, like so. Okay. Here's our a value. Okay. We don't have a c value, so the c is really plus 0. Okay. Our b value is 1 over 2, and then our d value is negative 4. So based on all of that information, we can come up with our mapping notation formula. xy becomes 1 over half is going to give us 2x, and then this plus 4 means we're translating 4 units to the left, so we're going to subtract 4. And then the 3y plus 0, or just 3y, is going to be our vertical stretch by a factor of 3. Okay. So I'm just underlining in the same colors to show you where we're getting the formula from. Okay. So once you have that, then you can just use the base graph points for root x, which are 0, 0, 1, 1, 4, 2. Okay. The next one is going to be 9, 3. We're not going to have enough room to include that point, so we'll just leave it out. Okay, so these 3 points are sufficient. So for each of our x values, we're multiplying by 2, subtracting 4. Times 2 minus 4, times 2 minus 4. Okay. For each of our y values, we are just multiplying by 3. So once you have these points, again, you can just plot them down on your axes. Again, please make sure you always number your scale. So we have negative 4, 0 right there, negative 2, 3 right there, and then we have 4, 6 up here, like so. And we're just going to draw like that. Put an arrow on the end that continues. Just make sure you don't put an arrow on the origin point at negative 4, 0. Okay, in this example here, if we could do equivalent transformations, I might recommend it, but in this case, this square root of half, that's not going to turn into a very nice number when we bring it out of the square root, so we're just going to keep this as is. But as with all of our other examples, we always need to factor out the b value. So we're going to take out negative half from negative half x minus 1. So we're going to have x plus 2. Because when you do negative 1 divided by negative half, it's the same thing as negative 1 times negative 2. So that's how we get this plus 2 there. Okay, and then we'll have the plus 3 on the outside. So here's our a, here's our b, here's our d, there's the c. Okay, and we're going to use our mapping notation formula. xy becomes 1 over bx plus d, ay plus c. So 1 over b will be 1 over negative half, which turns into negative 2x. And then plus d is going to be minus 2, because we're translating 2 units to the left, so that's why it's subtracting 2. And then ay plus c will be 2y plus 3. So again, I'm just going to color code here. So this a value of 2 is this 2 in front of the y. The plus 3, translation 3 units up, is there. The b value of negative half turns into 1 over b in the formula. And then the x plus 2 turns into minus 2. Okay. So again, once you have this formula, you just need to write down your base graph points. 0, 0, 1, 1, and 4, 2. And then those base graph points are going to be transformed as follows. So negative 2, 3. Negative 2 minus 2 will be negative 4. 2 times 1 plus 3 will be 5. Then negative 2 times 4 is negative 8 minus 2, negative 10. And then 4 plus 3, 7. Okay, so those are the 3 points that we're going to have to show on our grid for the graph. So now we have negative 2, 3. We have negative 4, 5. And then we're going to have negative 10 and 7. Okay, and there's our root function. Again, make sure you put the arrow on the end that continues. Don't put an arrow for the origin point. So let's move on to the next example. For this one, we have our rational graph or reciprocal function. So we have our y equals negative 1 over x and then plus 4. So actually I'm just going to go right into my formula. There isn't really anything to common factor or anything like that. So xy is going to become, a value is in the numerator, it's just 1. Okay, it's up to you if you want to include this negative or not in the a value. Okay, so either you include it with the a or you put it in with the b. So it doesn't matter either way. Okay, so in this case, if you do want to include it with the a, then that means that we should highlight the negative with our 1, like so. So there's going to be our a value right there, -1, okay? Which means that our b value in front of x is just 1, okay? Our d value is nothing, it's 0, no horizontal translation. Our c value is going to be this +4, 4 units up. So with all of that in mind, we can write down our mapping notation formula as xy becomes x -y plus 4. So the -y, because we said that a is -1, and then the +4 because of the 4 units up. Okay. So now that we have this as our mapping notation formula, we just need to write down our base graph points. We have -2, -0.5, -1, -1, -0.5, -2. Okay. We have 0.5, 2, 1, 1, 2, 0.5. Okay. So all of the x coordinates will stay where they are, so we just have to copy those down. Okay. And then for our y coordinates, we're going to switch the sign and then add 4. So that's going to cause our reflection in the x-axis and our translation 4 units up. So we'll have -0.5 plus 4, so that's 4.5. +1 plus 4, 5. +2 plus 4, 6. -2 plus 4, 2. -1 plus 4, 3. -0.5 plus 4, 3.5. Okay. So then once we have those points, we'll be able to plot them down along with our asymptotes. Okay. So -2, 4.5. -1, 5. -0.5 and 6. And we have 0.5, 2, 1, 3, and 2, 3.5. Okay. So now we are going to draw our graph, our 2 arms of our graphs, like so. Okay. And then the next thing that we need to do is we need to put down our horizontal and vertical asymptotes. So when you look at the D and the C values, that's what's going to tell you where those asymptotes should go. So we have our horizontal asymptote at, or vertical asymptote rather, at x equals 0, because we did not translate anywhere, so the vertical asymptote will stay where it is. So I'm going to dot my line or dash my line down and write the equation, and then my horizontal asymptote is going to be across y equals 4 because of my translation 4 units up. And that's it. That's my graph of the rational. Okay. Now let's try another example. So now for our last one here, we are going to have to first factor. So we have y equals 2 over 3 bracket x plus 6 divided by 3 will give us 2 plus 1. Okay. So here's our a value. Actually, sorry, I'll just circle or box around. Here's our a value of 2. Here's our b value of 3. Here's the d value of -2. And then here's the c value of +1. Okay. Because our rational functions are always in the form a over b, x minus d plus c. So based on that information, we can write down our transformation our mapping notation formula as xy becomes 1/3 x minus 2, and then 2y plus 1. And this is the 1. There's the, oh sorry, wrong color. There's the 2 for A. The B value of 3 turns into 1 over 3 for 1 over B. And then we see x plus 2. That means we move 2 units to the left, so that's why you see minus 2 there. Okay. So now we're going to take our formula. We are again going to just write down all of our base graph points and then transform them accordingly. Okay. So first one is going to be negative 2/3 minus 2, negative 2 and 2/3, and negative 1 plus 1, 0. Negative 1/3 minus 2, so negative 2 and 1/3. Negative 2 plus 1 is going to be negative 1. This is negative 1 over 6 minus 2, so it's negative 2 and 1/6. And then negative 4 plus 1, so it's going to be negative 3. Okay, so we have 1/6 minus 2, so that's going to be negative 1 and 5 over 6. 4 plus 1, 5. 1/3 minus 2, so that's negative 1 and 2/3. And 2 plus 1, 3. And then we have 2/3 minus 2, so that's negative 1 and 1/3. And then 1 plus 1, 2. Okay. So again, once you have your coordinates, okay, number your axes very carefully. So negative 2 and 2/3 and 0, like right there. Negative 2 and 1/3 and negative 1 right there. Negative 2 and 1/6 and negative 3 right there. And that will give us our first arm of our graph, like so. And we have negative 1 and 5/6, 2, 4, 5 right there. Negative 1 and 2/3 of the way, and that'll be 3. Negative 1 and 1/3 of the way, and 2, and that'll give us this graph arm here. Okay. And again, in terms of your asymptotes, those are going to depend on your D and C values. So because we have a translation 2 units to the left, that means that we should have our vertical asymptote at x equals negative 2. And our translation 1 unit up means that we should have our horizontal asymptote at y equals 1. And on the next page, we'll go over some irregular functions and how to continue applying mapping notation to graph those transformed functions. So for this page, we have irregular functions. For these ones, it really would be best and probably most efficient method to use the mapping notation method rather than like multiple graphs, for example. Can't really use the floating origin method for this irregular graph. Okay, so we are going to, first of all, make sure we understand that this is the function y. So this is the graph of y equals f of x. So to help us see what these points are later on, let's just label the axes very clearly. -2, -4, -6, -2, 2, 4, 6, 2. Okay, so now when we look at the transformed function given to us here, this is our b value, okay? This is our c value, and once we common factor out the b value, we know that we're going to have the proper d value as well. So this is going to be f of 2x minus 4 plus 1. So there's our d value here. Okay, so that means that this function is going to be horizontally compressed by a factor of half, and then translated 4 units to the right and 1 unit up. Okay, so in order to achieve this, let us write down our mapping notation formula and our base graph points, and then we'll get the transformed graph that way. So for our mapping notation formula, we're going to write down x, y becomes half x plus 4, and then our y plus 1. Okay. So the half is because of our horizontal compression by a factor of half. Plus 4 is our translation 4 units to the right, and then the plus 1 will be our translation 1 unit up. So now let's write down our base graph points. -6, 2, -4, 2, we have -2, -2, and then we have 2, 0, and then we have 4, 2, and then we have 6, 0. I know some of the points are a little bit off, but we'll try to get them on the grid lines. Okay. So once you have these 1, 2, 3, 4, 5, 6 base graph points, you can now start transforming them, and then we'll plot down our final result afterwards. So we have -3 plus 4 is 1, 2 plus 1 is 3, -2 plus 4 is 2, 2 plus 1 is 3, -1 plus 4 is 3, -2 plus 1 is -1. We have 2, 0 is going to become 5, 5, 1. Okay. We have 4, 2 is going to become 6, 3. And then we have 6, 2 is going to become 7, 3. Okay. Oh, sorry, I think I made a mistake for this last point. Let me just correct that here. So this should be 6, 0, and that should be 7, 1. That makes more sense. Okay, so I'm just going to plot down these final points that I just got. So that's going to give me 1, 3, 2, 3, 3, -1, 5, 1, 6, 3, 7, 1. Okay, so I'm going to draw with a ruler if possible, like so, and then like so, and then, and I'm just gonna make this part you can see is a semicircle, so that means these last points have to be connected in a semicircle shape as well. So here I go, and there's my transformed function, horizontally compressed by a factor of half, translated 4 units to the right and 1 unit up. Now let's take a look at this next example. We have our a here is -1. So it's been reflected on the x-axis. And then we have a b value of -2. That means it's been reflected on the y-axis as well as horizontally compressed by a factor of half. And let me label my axes here. 2, 4, 6, 2, -2, -4, -6, -2. Okay, and then for my mapping notation, for our mapping notation, we're going to have x, y becomes -half x, -y. So this -half x, that's for our horizontal compression by factor of half and the reflection on the y-axis. And then this -y will take care of the reflection on the x-axis. Now let's write down our base graph points. We're going to have -6, 0, -4, -2, -2, 0, 2, 2, and then we'll have our flat part of the graph, 4, -2, 6, -2. So we want to take this function and reflect in both axes and also horizontally compress by the factor of half. So let's see what all of these points will become. This will be, so -6, 0 is going to become 3, 0. Okay. -4, -2 is going to become +2, 2. -2, 0 will become +1, 0. 2, 2 is going to become -1, -2. 4, -2 will become -2, 2. 6, -2 is going to become -3, +2. So again, we're just going to plot down these points and connect them into our final transformed graph. So we're going to have 3, 0, 2, 2, 1, 0. Now, if you remember, these 3 points were part of the semicircle. So that means that these new 3 points are also my semicircle. So I'm going to have to draw my semicircle here. Try that again. Okay. There, a little bit better. So then my next point is at -1, -2, then -2, 2, and then -3, 2. And for those, I should just use a ruler. So here I go. My shape tool on my notes. Oh, there we go, a little bit better. And the last part here. Okay, and that would be my transformed graph. Horizontally compressed by a factor of half, reflected in both axes. And let me just highlight this in yellow in case it's a little bit harder to see. And semicircle. Okay, for this last example, here we go. We have our a value of -half. So that means that we have a reflection on the x-axis and a vertical compression by a factor of half. And then we have this translation of 4 units to the left. Four units to the left, and we have our translation 1 unit up. So let's write down our mapping notation formula. X, y is going to become we're going to have x minus 4 for 4 units to the left, negative half y plus 1 to take care of the the vertical compression by a factor of half, the reflection on the x-axis, and the translation 1 unit up. That's our A, here's our C, this is our D. Okay, and because we don't have a B value, that means that this B value in front of x is just 1. Okay. Now let's figure out our base graph points. Again, to help us with that, let's just label our axes. Scale 2, 4, 6, 2, negative 2, negative 4, negative 6, negative 2, negative 4. So our base graph points are going to be negative 6, negative 4, negative 2, 0, 0, 2, 2, negative 1, 4, negative 3, 6, negative 3. Okay. Now let's transform these points according to our mapping notation formula. So we have negative 10, and then we're going to have, this is going to be 2 plus 1, 3. Okay. Negative 6, 1, negative 4, negative 1 plus 1, so that's going to be 0. We have negative 2, it's going to be half plus 1, so 1.5. We're going to have 4 minus 4, which is 0, and then positive 3 over 2 plus 1 is 5 over 2, or 2.5. Then we have 6 minus 4, 2, and then positive 3 over 2 plus 1, oh, again, 2.5, that was helpful. Okay, so these are our final transformed graph points. So let's just plot these down. So negative 10, 3, 6, 8, 10, 1, 2, 3, right there. Negative 6, 1, right there. Okay. We have negative 4, 0, right there. We have negative 2, 1.5, right there. We have 0, 2.5 up here. And then we're going to have 2 and 2.5 up here. Okay. So we're going to connect the first 2 points using a line. And then if you notice, this part is going to get a little bit trickier here. This is the curve like so. That means that for this function, the curve has to come down like this because this has been reflected on the x-axis. Okay, so now it's going to look like this. So over here, it has to curve down like so. Okay. And then the next portion is another line, so let's just make a line like that. Okay. The next portion is this curve like so, but when you reflect on the x-axis, that means it's now going to be curved like that. So we now have to curve like so. And then the last portion is just a straight line going across like that. Okay. If you are ever unsure of what the shape of a curve should be, you can always plot a few extra points. Okay, you can include a few more base graph points here to make your final sketch more accurate. Okay, but that's it. That's how you graph using mapping notation formula.